Section 3.2, Measures of Variation. The number that we use to measure the variation are the range, standard deviation, and variance. In this section, we are going to learn how to calculate these three. The round-off rule for measures of variation. When rounding the value of a measure of variation, carry one more decimal place than it is present in the original set of data. So if your original set of data has one decimal place, then you are going to carry two decimal places for the measure of the variation. The range of a set of data values is the difference between the maximum value and the minimum value. To find the range, you are going to take the maximum value minus the minimum value. The range uses only the maximum and the minimum values, so it is very sensitive to extreme values. The range is not resistant. Example 1. Find the range of these Verizon data speeds. So here are the 5 data values that are given to me, and I am going to find a range. So to find a range, I need to first identify the minimum value and the maximum value. So to find a range, I'll take the maximum value minus the minimum value. So the answer is 41.50. If you notice, my original data values have one decimal place. The range will carry two decimal places. Next, we are going to learn how to calculate the standard deviation. The standard deviation of a set of sample values, denoted by S, is a measure of how much data values deviate away from the mean. We use S to represent the sample standard deviation and sigma to represent the population standard deviation. The formula for sample standard deviation is square root of the sum of x minus mean square over n minus 1. Or you can also use this formula, square root of n times sum of x squared minus sum of x squared over n times n minus 1. You can use either one of these formulas, so it doesn't really matter which one you're using. Example 2. I need to find the standard deviation of this data set. To find the standard deviation, I will need to find the mean first. So in the previous section, I already found the mean of this data, so I am going to just write it down because I already found it. To find the sample standard deviation, I am going to use this formula. So I'm going to take x minus x bar squared over n minus 1, and then I'll take the square root. So the first step is we take x minus x bar. So what is x? X are the values in the data set. So x can be 38.5, x can be 55.6, x can be 22.4, x can be 14.1, x can be 23.1. So in order to organize all of this, I am going to put it into a table. So I list all of my x's here. Next, I am going to take x minus x bar. So I'm going to take 38.5 minus 30.74, 55.6 minus 30.74, 22.4 minus 30.74, 14.1 minus 30.74, 23.1 minus 30.74. Then I am going to take x minus x bar square. So I am going to take 7.76 square, 24.86 square, negative 8.34 square, negative 16.64 square, negative 7.64 square. Then I am going to add all of these numbers up. Next, I am going to put everything into this formula right here. So the numerator is the sum of x minus x bar squared, which is the number that I found here, 1110.052. Over n minus 1. So n is the number of data values that I have. 1, 2, 3, 4, 5. (1110.052) divided by 4, I get 277.513. And then I'll take the square root of this. Right, so my calculator gave me 16.65872,144. How many decimal places should I use? So I go back to my original data right here. The original data values only have one decimal place. That means my standard deviation should have 2 decimal places. So my S is 16.66. To identify the significant values, we are going to use the mean and standard deviation. So on the number line, I will have the mean in the middle. This number is going to be the mean plus 2 times standard deviation, which is called the number that is 2 standard deviation above the mean. This number is the mean minus 2 standard deviation, which is the number that is 2 standard deviations below the mean. So any value within this range of number are not significant. Any value that's higher than this number is called significantly high values. Any value below this number is called significantly low value. For example, on the example earlier, remember we have our mean is 30.74 and our standard deviation is 16.66. So in order to identify the significantly high and significantly low, I would do the same thing here on the number line. I'll have my mean here, which is 30.74. And then I have my mean plus 2 standard deviations. So 30.74 plus 2 times 16.66. And then this number is the mean minus 2 standard deviations. I have 64.06 is the number that is 2 standard deviations above the mean. And the number negative 2.58 is the number that is 2 standard deviations below the mean. So any number within negative 2.58 to 64.06, we call them not significant. Any number that is larger than 64.06 are significantly high. And any number that is below negative 2.58 are significantly low. So if you go back to look at these data right here, none of those are significantly high or none of those are significantly low. So we call these numbers are not significant. When you want to roughly estimate the standard deviation, you can use this range rule of thumb. We take the range divided by 4 just to get a roughly estimate of the standard deviation, which means we are going to take the maximum value minus the minimum value and divide it by 4. To find the standard deviation for a population, we use a similar formula, except for one thing that's different, which is this number down here. So instead of divided by n minus 1, for the population, we divide it by n. So sigma equals square root of the sum of x minus mean square over the population size. Variance. The variance of a set of values is a measure of variation equal to the square of the standard deviation. So to find the variance, we take the standard deviation and we square it. So to find the sample variance, we take S squared. To find the population variance, we take sigma squared. Here are the notation. S stands for sample standard deviation. S squared stands for sample variance. Sigma stands for population standard deviation. Sigma squared stands for population variance. Example 3. Find the variance of this data. In order to find the variance, we need to have a standard deviation. So we already found the standard deviation of this data from the earlier example. To find the variance, we take the standard deviation and square it, which is 16.66 squared. And we have 277.5556. How many decimal places should we use? Remember, we look at the original data. This has 1 decimal place. Then my variance should have 2 decimal places. To find the range, standard deviation, and variance using StatCrunch, we first need to import the data into StatCrunch. Then click on Stat, Summary Stats, and Columns. Choose a column, choose the variance, standard deviation, and the range. Compute. This is your variance, this is your standard deviation, and this is your range. Empirical rule. The empirical rule states that for data sets having a distribution that is approximately bell-shaped, the following properties apply. About 68% of all values fall within 1 standard deviation of the mean. About 95% of all values fall within 2 standard deviations of the mean. About 99.7% of all values fall within 3 standard deviations of the mean. What does that mean? So I have a graph of my data that is a bell shape. This is my mean. This number is mean plus standard deviation, which is 1 standard deviation above the mean. This number is the mean minus standard deviation, which is 1 standard deviation below the mean. So the empirical rules say that everything from this number to this number will be 68% of my data value. This number is the mean plus 2 standard deviations, and this number is the mean minus 2 standard deviations. From here all the way to here, they contain 95%. This number is the mean plus 3 standard deviations, and this number is the mean minus 3 standard deviations. From this number all the way to here, it will contain 99.7%. Example 4. IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. What percentage of IQ scores are between 70 and 130? Right, so first we are going to draw the graph. It's a bell shape. The mean is 100. And the standard deviation is 15. So to get to 1 standard deviation above, I take 100 plus 15. To get to 2 standard deviations above, I take 100 plus 15 plus another 15. And then plus another 15 to get to 3 standard deviations above. And then to get to the one standard deviation below, I take 100 minus 15 minus another 15. From 85 to 115, that is one standard deviation within the mean, which is containing 68%. From 70 to 130, that is two standard deviations within the mean that contains 95%. 55 to 145 is within three standard deviations of the mean, which contains 99.7%. And in the question, they ask what percentage of the IQ score are between 70 and 130. So between 70 and 130, that is within two standard deviations within the mean. So that contains 95%.